Hey folks, I'm Youssef. I am a Databricks Solution Architect, and as you can see, I'm a big Delta Lake fan. In the first video, we talked about the benefits of using column mapping. Today, we talk about deletion vectors. Keep in mind, in order to run the notebooks I do have, you have many options. You can install Apache Spark, Delta Lake on your laptop, or you can just go and register or sign up for the Databricks Free Edition. For now, let's just talk about deletion vectors. So they are like a storage optimization feature in the Delta Lake that enables efficient delete, update, and merge operation by avoiding full rewrites of Parquet files when rows are changed or deleted. Instead of physically removing the data, deletion vectors mark row position as logically deleted via compressions, bitmap files, and implementing a merge on read paradigm. When you enable deletion vectors on a table, modifications write metadata about deleted rows, and queries merge this information at read time, ensuring acid consistency. Now, let me show you in the platform how you can get started. Now that I am in the free edition page, I already have an account, so I will just log in, select my account, and then I can choose the notebook I want. I already have one called Delta Lake Deletion Vectors. Now that I am in the Deletion Vectors notebook, I'm gonna run everything. As you can see, I will create my catalog called Youssef_demo. I'm gonna create my schema called test. I'm gonna import some basic Python functions. I'm gonna create some fake data. And as you can see, I created more than 2 million orders, rows with 16 columns. And then I'm gonna create two different delta tables. The first one where I have deletion vectors disabled, and the second one with deletion vectors enabled. And then I'm gonna create some new multiple column, multiple orders with 200K orders. Some of them will be new orders and others will be updates in order to showcase the benefits when enabling deletion vectors with the merge operations. And now I will run this merge performance. The first one where I have deletion vectors not enabled. So the condition is the order ID equal to order ID. When this condition is matched, then I'll be updating my existing table. When this condition is not matched, then I will insert this new data. And as you can see, merge without deletion vectors took 5.28 seconds. I will repeat the same operation with the same data, but this time with deletion vectors enabled. And let's go and check. You will see that with deletion vectors, it's took 4.78 seconds. So deletion vectors are 1.1 faster for merge. Of course, this is just a short, small subset of the data, but with large data set, you can see that the performance can be much, much bigger. And that's really the perks of using deletion vectors. So keep in mind, deletion vectors are awesome when it comes to merge operations, where you have CDC, which changed data capture. I'm talking about CDF for streaming upserts. The goal is to not rewrite the Parquet files at every single operation, and it's massive time saving for large tables. Again, this is just small subset of data, but imagine for terabytes of data, it would be massive time saving. And how you can enable it. So I did show you how to do it in Python. In SQL is the same thing, create table orders, and you add the table property delta dot enable deletion vectors equal to true. So make sure to use again deletion vectors because it's can save you a lot of time, and also it's part of many functions we will be showcasing, such as liquid clustering. So now it's your time to go and try deletion vectors. The notebooks will be on the GitHub repo, and make sure to use your OSS configuration or the free edition. Bye.